Hi guys, welcome grade 6-7s. This is a video to accompany the grade 6 and 7 work for Tuesday, April 14th, and we're going to learn about adding mixed fractions. I will use some of the examples right from your work so that hopefully you can follow along, and if you get stuck, you can go right slide by slide. So, first slide is just what we know. We know that when we add fractions with like denominators, we add the tops and we bring the bottoms across. So for example, if we have 2/6 plus 1/6, then my numerators are different up here. So I add the numerators and the denominators. As long as they're the same, I can just bring them across. We're not doing anything with them other than keeping them as sixths. So another example would be 5/7 plus 1/7. If the denominators are the same, then the denominator just comes across and we add the top or the numerator. 5 plus 1 is 6 and we have 6/7, right? Easy enough to start. Then we have a bit of a video from our math guy, Math Antics, who really explains to us quite well what we need to do. So watch the video and then I will go through the math after that to explain what he already did. So sometimes we have something called a mixed fraction. We will remember that a mixed fraction has a whole number and a fraction piece. So 5 7/8 is a whole number and a fraction piece. And sometimes we want to add these mixed fractions. And we're going to work with them today so that both of them have the same denominator. Life is much easier when they have the same denominator, and this is a great first step. So what we're going to do, according to our Math Antics guy, is that we could add them this way, going across, but in some cases it might be easier to add them going down. So I'm just going to rewrite the question going down, as though we're doing a stack and add. All right. So there's exactly the same question, but now we've just done it as a stack and add. So the first thing I want to do is add the whole numbers. So that would be 5 plus 8. So over here, I'm just going to keep track of what I'm doing so I can show some math. I ask you on the slides to show the math, which I know is so hard to do on a computer instead of on a smart board or on a piece of paper or on a whiteboard like I'm using here. But really, I need to sort of see where you're getting the work from. So I'm just going to keep track of it over here. So 5 plus 8 is 13. So I'm going to write 13 under my stack and add. The next thing we're going to do is we're going to add the fraction bits. Because they're both 8s, our denominator is going to be an 8. Easy enough. So then all I need to do up here is add the 7 and the 5. Those are the two numerators for our fraction bits. And 7 plus 5 is 12. So I'm going to come back over here and I'm going to put 12 as our numerator. Now your brain should be going off and you should be saying, wait a minute, but 12/8, this fraction right here that we've created, that is an improper fraction. And we do not like an improper fraction. So I can take 8 of this 12, because 8/8 make one whole. I can take 8/8 out of there and I can add it to my whole numbers. So my new whole number is going to be 14. My denominator is still 8s. We have not changed that at all. Now I've used 8/8 out of my 12 and I have 9, 10, 11, 12, 4 left over. So I'm going to put 4 left over right there. So our answer was 13 12/8, but that is with an improper fraction. We've now taken one whole, or 8/8, out of our improper fraction and put it to our whole numbers, and we've put our remainder of 4/8. Now your smart grade 6-7 brain should also be looking at that and saying, wait a minute, 4/8 can be reduced. So you are correct. I can divide the top and the bottom by 2. 4 divided by 2 is 2, 8 divided by 2 is 4. And then your brain might say one more time, wait a minute, that is still reducible. So I have 14 and 2/4, and I can divide the top and the bottom by 2, and I can get 14 and 1/2. I'm not as concerned about the reducing, but I for sure want us to practice this adding mixed fractions. Okay, let's go to the next screen. So this is giving us another practice one. This one is one that's already been done for you. You just sort of need to follow along so that you get a better understanding of what's going on. All right, so here's our math sentence. 3 and 6/8 plus 7 and 5/8. Now I'm going to do it this way. The last time I did a stack and add this way. I'm going to do it this way across, but I still want to keep track of a little bit of my work so I see what's going on. So first thing I'm going to do is add my whole numbers. 3 plus 7 equals 10. So I know I'm going to have 10 wholes. So I'm going to put my answer of 10 over by my equation. Hope you can see that. Now I'm going to add, I'm still going to deal with 8s in my denominator. So now I'm going to add my numerators. My numerators are 6 plus 5. So over here I'm going to keep track. 6 plus 5 equals 11. So I'm going to put up here 11/8. So my answer is 10 and 11/8. But again, if I look at 11/8 and I see that that is an improper fraction, I need to turn it into a better mixed fraction. So I've got to figure out how many times does 8 go into 11? And it goes once. So I can take out 8 from here, and I can make one whole. And I will have 3 left over. So while 10 and 11/8 is correct, to turn it into a true answer, I need to make it 11 and 3/8. All right. The next screen wants us to practice. So we're going to do it one more time just to make sure we know exactly what we're doing. 2 and 3/4 plus 6 and 1/4. And I'm going to follow the math antics guy, and I'm going to do a stack and add this time. You can see I go from both ways of doing it, and it works equally well, whichever one you like the best. The stack and add is sometimes easier to see what I need to add when. So the first thing I'm going to do is I'm going to add my whole number. So I'm going to keep track of what I'm adding. 2 plus 6 equals 8. So I'm going to bring 8 down here. Now I'm going to add my fractions, or my numerators. 3 plus 1, because my denominator is going to be 4. 3 plus 1 are my numerators. I'm going to add them together and also get 4. Now when I look at this, 8 and 4/4, my grade 6-7 brain should be looking going, wait a minute, 4/4 really equals 1. So my answer is actually going to be 8 plus 1, which equals 9 wholes. And in this case, I don't need to put a fraction here because we've used the fraction and we've turned it into another whole right here. Okay? So I think we get the point of this one. The next 1, 2, and 3 slides are asking you to show your work and add mixed fractions with like denominators. There are 2 sort of real life practices, one involving myself and Miss Sparrow, and one involving Max and some wood. So give this a go. If you have any questions, email me always. But otherwise, that should explain how to add mixed fractions with like denominators. Chat soon. Bye.